If you've ever been out at night looking for constellations, chances are you've seen the stars in the saucepan. They're pretty recognisable because they're all bright and they're all pretty close together, right? Well, maybe not. For starters, the saucepan isn't actually a constellation at all, it's part of a much larger pattern called Orion. The base of the saucepan forms Orion's belt, and the handle of the saucepan forms his sword. The rest of Orion looks a little something like this, unless you're the ancient Greeks who named him in the first place, in which case he looks more like this. Astronomers describe constellations as if they were points on the inside of a giant dome, and for a lot of history that's what we thought the sky actually was. But of course, the sky isn't a giant dome, it's outer space, and while that might seem really obvious, thinking about the sky as a giant dome actually pervades a lot of how we think about outer space. For example, you might assume that the stars in a constellation like Orion are, if not flat, then pretty close together. It makes sense. But suppose we left Earth and looked at Orion from the side. It wouldn't look like this. It'd look like this. So because stars are drifting through space rather than being fixed, that means they do actually move, and constellations will change over time as well. Because the stars in Orion are so distant from each other, they are pretty resistant to this type of change. The Orion that the Greeks spotted thousands of years ago is the same one we can see today, more or less. The biggest change you can expect for Orion in the next million or so years is that Betelgeuse on Orion's shoulder will explode in a supernova that will be visible during the daytime. Even weirder, this might already have happened, and the light just hasn't reached us yet. So if these stars are all so far apart, how come they all look about the same brightness in the night sky? Well, it turns out that in space, unlike here on Earth, brightness depends on a lot more than just size and distance away. On Earth, something bigger would be easier to see, but out here in space, neither size nor distance is as important as colour, or rather temperature. The hotter a star is, the closer to the blue end of the spectrum it is, and the brighter it looks in the sky. The cooler it is, the closer to the red end of the spectrum, and the dimmer it appears in the sky. So despite its huge size, Betelgeuse is actually slightly dimmer than Rigel because Rigel is just that much hotter. And to complicate things even further, some of these stars aren't actually just one star. Olmütük, Mintaka, and Meissa are actually double stars orbiting each other. While most of the time their brightness is added together, occasionally one will pass in front of the other and block its light, leading to a slight dip in its apparent magnitude. And that just barely scratches the surface. If you're interested in looking a little bit deeper than your humble saucepan, astronomy is one of the easiest branches of science to get into because you already have all the tools you need. Just print yourself a star chart, take your eyes outside, and go find something interesting. Thanks for watching.